Oil and gas processing facilities are complex systems involving feedstock reception, processing, storage, and product shipment. In the era of digital transformation, digital twins and simulation modeling have become powerful tools for supporting operational and planning decisions in the oil and gas industry. To facilitate the development of realistic digital twins of oil and gas facilities, the Petroleum Refining Library for AnyLogic was created. Petroleum Refining Library supports the development of digital twins for oil and gas facilities. It enables production planning, product shipment scheduling, scenario analysis, process optimization, and bottleneck identification, helping engineers make effective operational and strategic decisions. Petroleum Refining Library is fully integrated into the AnyLogic simulation environment and provides a comprehensive set of components for modeling oil and gas processing facilities, including process units, tank farms, sources, and blending and splitting nodes. Flexible settings and parameters allow engineers to accurately represent real-world assets. In addition, Petroleum Refining Library includes a large collection of Java-class templates that provide powerful modeling capabilities and simplify the further development and customization of models in AnyLogic. Petroleum Refining Library is intended for engineers and researchers developing digital twins for oil and gas facilities. By providing ready-to-use simulation infrastructure, it allows users to focus on solving real industrial challenges. To demonstrate the capabilities of the library, let us consider a simplified gas condensate processing plant. A condensate stabilization unit operates in two modes, stabilization and deethanization, producing several products that are accumulated in dedicated tank farms before shipment. Because the LPG storage capacity is limited, the operating mode must periodically switch when storage is full or production targets are achieved. The model records product flows and enables engineers to evaluate production plans and analyze facility utilization. Let's do it with Petroleum Refining Library. The model of this gas condensate processing plant is implemented in AnyLogic using the Petroleum Refining Library. It includes feed sources, a condensate stabilization unit, tank farms, and product dispatch nodes. The feed sources simulate the inflow of unstable gas condensate from upstream fields. They support various planning modes, including monthly and daily schedules, as well as flow smoothing options. In addition, the sources provide a wide range of parameters and events that allow their behavior to be represented in detail. The feed sources are connected to the condensate stabilization unit, which enables flexible configuration of the separation rules for unstable gas condensate and the resulting output streams. The stabilization unit is connected to the tank farms, which also provide extensive configuration capabilities. One of the key mechanisms is the handling of product withdrawal requests. Tank farms support different request priority schemes, allowing their operation to be represented more accurately. In this example, only priority A is active, indicating that the tank farms must be filled to ensure that the current month's shipment targets are met. The product dispatch nodes dynamically monitor plan execution and support different withdrawal strategies, including maximum rate operation, uniform withdrawal, and daily scheduled withdrawal. Let's take a look at how this model operates. After the simulation starts, the feed sources begin sending unstable gas condensate to the stabilization unit according to the specified production plan. The feed then enters the stabilization plant, which consists of two process lines. At the moment, one line is operating in stabilization mode, while the other is operating in deethanization mode. At certain periods, both lines switch to deethanization mode simultaneously, as shown now. This behavior is caused by the limited capacity of the NGL receiving tank farm, which periodically becomes completely full. When both tanks are filled and no additional NGL can be accepted, the plant automatically switches to deethanization mode. If we accelerate the simulation, we can see that as storage capacity becomes available again, one of the process lines returns to stabilization mode, while the other continues operating in deethanization mode. In addition to the NGL Reservoir Park, the model includes several other parks. However, due to their large capacities, they do not significantly affect the operation of the process unit. As time progresses, production targets for all product streams are successfully achieved. At the same time, the product dispatch nodes gradually approach 100% completion of the scheduled shipment targets. This example demonstrates how the Petroleum Refining Library for AnyLogic can be used to model real-world oil refining and gas condensate processing facilities with a high level of detail. Thanks for watching. Please visit our website for more information.